Welcome to our presentation. We just want to introduce you to the projects we have been working on with Forge in the recent years. Who are we? We are a research center at the Technical University of Munich that has 5 chairs under its hood. So we basically cover all digital methods in the built environment. We have a lot of industry partners that work together with us on quite interesting research questions. And we also have, as you can see on the slide, several public bodies as partners in our projects, and they all provide very useful insights for us and help us with the collaboration on very different levels. We have around 60 researchers working currently at our LOC, and covering all companies that work together with us, we have around 60,000 people working together with us. So I will quickly jump directly into the results and hope to don't waste that much of your time starting to get some beer. The first of our 3 projects we want to present is one about progress monitoring. So basically, we had a research project that focused on automated progress monitoring, and we were thinking about how to get the results of the progress monitoring directly to building manager, all related people to the project. And we were thinking, okay, we need something that doesn't need any installation, that works quite fast, and that is easy to understand. So we decided to use Forge for that. So we have a browser-based application. In this case, we used the model derivative API and the visualization, as you can see here in the screenshot. And one of the biggest benefits for us is that we can also use IFC as, we are in university, we need to try to support open standards. And as you can see in this video, it's quite easy to view the status of the building on different times of observation. We have we classified the model based on certain detection states, and you can easily filter them and get a very initial and easy grasp where we are standing in our project. So you can see direct information on all elements, and it's quite easy tool. I mean, it doesn't do that much, but it helps very easily to get information on the project. For the next project, I want to hand over to Simon, who will present you something on classification.
Thank you so much. I want to show you something about a little student project we had that was actually funded by Autodesk, and what I want to talk about is classification in BIM models. So first of all, what is classification and why do we need it? Imagine that you're not designing like a normal building, but something like an infrastructure facility where you have to use a lot of generic families, for example, in Revit, or when you have an IFC file, you have a lot of proxy objects, then you somehow need to know what type of component you're dealing with when you're looking at a certain object. So you need to know that a certain abutment, for example, is an abutment and not only simply a wall. So in some projects that we work in, we do this by using semantic attributes that we add to our model elements that determine what type of building element is represented by a certain object in a model. And to actually integrate this into a Forge app, we created with using the BIM 360 API, the Model Derivative API, and the Model Viewer API. We created an app where a user can access any model stored in a BIM 360 account that he logs into, and then, of course, the model can be viewed first of all. In this case, the infrastructure facility as a bridge that is going to be built in Germany in the next couple of years. And first of all, it consists of a lot of different parts. And in this case, the model is based on an IFC file. And basically, all the objects in there are either proxy objects or or objects based on IFC classes that are not really very well suited for actually describing the model element that we are talking about in a certain case, because simply the IFC at its current state is not very well equipped for infrastructure, at least not the implementation that most programs offer so far. So what we can do now is by by the definition of standards, for example, that certain attributes define a model element in terms of a certain classification to either, well, of course, highlight all the models that have the same classification, for example, to just get a feeling what is what in a model. This can be either done manually by clicking on certain objects, or on the other hand, we can parse an XML file in a schema that we created, where this is basically a filter that defines what type of property leads to a certain classification in the model. So why do we need this in the end? First of all, of course, just to know what is what in a model, which is kind of easy in a normal house, for example, but not that easy in an infrastructure model. And in the next step, for model checking. This goes a bit into the same direction of what Lucien was talking about, but we were tackling this from the other side. So we didn't integrate it completely into Forge. Our classification system is just the first step, but we have created a tool where actually an employer can define what types of properties a certain model element, depending on its classification or on the building element type, needs to have in terms of the attributes. And this can be done very easily in a web interface. And we want to use this data, send it to Forge, so that based on the classification of modeling elements, the user can check if the attributing and the semantics of the model are correctly in the end, and do, well, a quick semantic model checking in the end just by using our Forge app. And with that, I will hand over to Sebastian, who will talk about teaching and Forge. Thank you.
Yeah, thanks so far. As you know, we are coming from a university, which means that we not only have time to build nice prototypes or nice apps, but also have to do a bit of teaching and doing a bit of research. What we are doing in the scope of Forge is, on the one hand, evaluate the existing Forge services, also in the terms of IFC support, and on the other hand, identifying concepts how to teach Forge technology or web-based technology itself inside our classes or courses. We are belonging to the civil and environmental engineering faculty, which means that we have civil engineers and environmental engineers. So they are not that familiar with coding or don't want to do that the whole day. So they must be like teaching the concept rather than teaching them the fanciest detail of a service. So what we've identified is such a workflow that we are able to teach them, like really using several APIs and also showing them what's already possible in the scope of using IFC. So in that sample, using existing Revit models and export them to IFC using Forge. What is the advantage of that workflow? Well, considering that I have 100 Revit models or something like that, and I want to export all of them towards IFC, I don't want to open every single model and press the export button, but I just want to upload all these 100 models, say, okay, or start the translation job, and once it is finished, I want to download the result. Well, there's no viewer in there. You can see the used APIs. It's not that fancy. That's the reason why there's no nice movie, but we can show them how to create some sample apps, but Forge-based or web-based. So accessing the web-based APIs, but on a desktop-based implementation. And you also can see the names of these grid views are really related to the used APIs, which is also a reason of teaching, to show them the concepts, to make a visual debugging possible. Also to use like the URLs inside other tools, just to show them what is possible and how to use such technologies. And we're not that far, so that's the reason why we cannot show that much about the teaching here. But if you have any questions, just feel free to reach out to us. Thank you.